All right, now that we're a little bit more familiar with our quad family tree, hopefully level threes will be okay for you. Again, it's just using those properties listed and either identifying angles or identifying diagonals and different lengths. So instead of just finding like numerical values like we did in level two where you're given like a specific angle measurement, now we're given expressions and we're asked to solve here. So in number 4, it says ABCD is a parallelogram with diagonals intersecting at E. BE has that expression x squared minus 6x, and BD is x squared minus 11x plus 20. Find ED. So it wants us to draw a diagram, and that is such a great strategy for you if you don't have a picture drawn for you. So here's my parallelogram, and I know it's A, B, C, D, and you just write them going clockwise or counterclockwise. Just don't go like across the figure when you're naming them. So like what I mean by that is don't go like A and then B over here and C in the top and then D in the bottom. So don't do that. Go either to the right in a circle or to the left in a circle. And you can start anywhere. You don't have to start in the upper left hand. That's just my habit. So B, C, and D. Okay. So ABCD is a parallelogram, and the diagonals are going to intersect at E. So here's E in the middle. Okay. Now it also tells us that BE is x squared minus 6x. So BE is x squared minus 6x. Then it tells us that BD is x squared minus 11x plus 20. So this whole segment is x squared plus 11x minus 20. Plus, nope, I mixed that up. So it's x squared minus 11x plus 20. Okay, now I got it. So I've got BE, which is little. I've got BD, which is large. So again, look at your quad family tree. Look at the diagonals of a parallelogram and see if you can figure out something that we can do. So go ahead and look and come up with a game plan. Okay, so hopefully you were able to figure out something about the diagonals. In particular, the diagonals for a parallelogram, remember that they bisect each other. So they will cut each other in half. It doesn't mean that they're equal. It just means that like when BD gets bisected, BE and ED are congruent. So I also know that this is x squared minus 6x. Okay, so if I'm solving for x, I can combine the two little pieces, x squared minus 6x plus x squared minus 6x, and set it equal to the whole length. Or I could also just multiply x squared minus 6x by 2. It's the same thing. Okay, so now I'm going to go ahead and solve this. Remember, if you have an x squared term and an x term, you want to get x's, everything on one side, and get it equal to 0. So I'm going to move this x squared over to the other side and move the 11. It'll be x squared minus x, and I'll also move the 20. Minus 20 equals 0. So I'm moving everything to the left-hand side. Now I'm going to factor it. So it's going to be x minus 5 and x plus 4. So x is going to equal 5, and x equals negative 4. Now hold on. We're not done yet. We have to make sure that we answered the question. We found out what x was, but I'm not sure that that is what it was asking. And sure enough, it's not. It's asking us to find ED. So what I'm going to do is I'm going to substitute the values that I got for x into the expression ED, which was x squared minus 6x. So I'm going to do a little if. So if x equals 5, ED equals 5 squared minus 6 times 5. So ED equals 25 minus 30. which equals -5. Now, I hope you have a confused look on your face, because you should, because can a segment or part of a shape or anything that we measure have a negative distance? I hope you're screaming at your iPad, no. It can't, okay? Nothing can have a negative distance. So the value of x equals 5 cannot be a solution, so we don't include that in our answer. So now, really, let's hope the only solution, or that x equals -4, works for this. Okay, so this would be -4 squared minus 6 times -4. Okay, parentheses are huge when you do this. Okay, and sure enough, this is going to get us 40. Okay, so we got a positive number. If it gave us another negative number, there would just be no solution for x. No solution that would apply to the geometry of it. So meaning that there is no positive distance. So our answer is 40, ED equals 40. We got that just by knowing something about diagonals in a parallelogram. Okay. All right, you do have to change one thing on number 5. It's just letters. It's no big deal. So it says EP is parallel to FQ. I want you to change that to IC. Okay, so I've got another node diagram, so I'm going to draw a trapezoid. Now, it doesn't say it's isosceles, so I can't mark the legs that are congruent. And it's going to tell me that EP is the parallel to IC. So I know that wherever I start, and say if I start down here, E, and I have got to go in a clockwise or counterclockwise, PIC, EP is not parallel to IC. I need the top ones to be the parallel ones. So knowing that, I got to move these around. So let's start here. E, P, I, C. Okay, so now I see that EP is parallel to IC. And I went in a clockwise position, so that's okay. I went in a circle, so we're good. Okay, so those are the ones that are parallel. E is 3x squared. And angle I is 3x. And angle C is 12x. And it wants us to find out what angle P is. So I'll put a question mark in there. Okay, so look at your trapezoid, not the isosceles one, because we just know that this is a trapezoid, and figure out what you know about regular trapezoids in terms of their angles. Okay, so I hope you said that since these lines are parallel, look at this as like the transversal, these two sides, these two angles are supplementary. Okay, they're right next to each other. So if they're supplementary, I'm going to take them, add them together, and set them equal to 180. So again, I've got an x squared and an x term, so I'm going to bring everything over to one side. And then to make this a little bit easier, I'm going to just divide everything by 3, just to make those numbers smaller. And then factor what's left over. It's going to be plus 10 and minus 4. So x is going to equal -10 and x equals 4. Okay, so again, we just need to make sure that both of the x values make sense first of all. So we're going to think about this. If x equals -10, which x can equal a negative number, we saw that from the one above. So if x equals -10, if we substitute that in for I, does that give us a positive angle measurement? It won't, because it'll give us -30. So right away, just because x equals -10 doesn't work for angle I, we can't include it as a solution. It just doesn't make sense with the geometry. Okay, so x equals 4 is our only solution. So if we want to go and find angle P, again, like the left-hand side, E and C were supplementary, P and I are supplementary. So if I find out angle I by substituting an x, which was 4, it's going to be 12. I'm going to take 180 and subtract it from 12, and that's going to get me 168, which is the measure of angle P. Okay, so a little bit more challenging in terms of setting up equations and solving. That's more level 3, and level 2 is just, finding numbers and values. Good luck.